Something is wrong with the universe. Something that should never happen is happening right now, and it is happening to an object racing toward our star. Its name is 3I Atlas, and it breaks the most fundamental rule of heat and light. As it approaches the sun, it gets colder. Every law of thermal physics tells us the same story. Closer to the sun means hotter. More solar radiation means more heating. More heating means rising temperature. Nothing in nature reverses that equation. Nothing freezes while diving into fire. What 3I Atlas does, its thermal readings drop with every astronomical unit it falls. Its surface temperature slides downward even as solar flux climbs upward. It is a thermal inversion so sharp, so absolute, so undeniable, that the data itself feels like a warning. Imagine watching an object drifting through the void. Imagine sunlight striking it harder and harder as it descends into the inner system. Now imagine that its thermal signature, instead of glowing brighter, fades, darkens, and then collapses into colder and colder values. A shadow inside a spotlight. This is not a glitch, this is not a sensor error, this is not a miscalibration. Multiple arrays confirm the same disturbing trend. 3I Atlas cools when it should burn. Scientists expected a rising thermal curve. What they found was a plunging thermal cliff, a perfect contradiction. A breakdown of cause and effect, a violation of the simplest rule every child learns. More sunlight equals more heat. Yet 3I Atlas rejects that rule with silent defiance. And so the question tears open the sky. What kind of object absorbs more radiation but emits less heat? What kind of surface brightens on the outside but freezes on the inside? What kind of structure grows colder in the heart of the sun's furnace? The thermal inversion paradox has begun, and its implications reach far beyond this single traveler. If 3I Atlas can break thermodynamics, what else in the cosmos might do the same? This is the story of an object that chills under fire, a wanderer that cools under the sun, and a paradox that forces us to question the physics we thought we understood. 3I Atlas is falling toward the sun, and with every kilometer per second, with every rising beam of radiation, it is getting colder. If this is true, then our understanding of heat, light, and matter is about to fracture. 3I Atlas first appeared as a faint anomaly in a deep sky survey. No one was looking for it. No one expected it. And for a brief moment, no one understood what they had found. The automated detection pipeline flagged it. A narrow streak across a field of distant stars. A sliver of motion where nothing should move. The alert reached the observational team minutes later, and within hours, the object had a name. 3I Atlas. The survey that discovered it was one of many wide-field monitoring programs. Dozens of telescopes scanning the sky, searching for near-Earth objects, transient flares, and unusual interstellar travelers. 3I Atlas matched none of the expected signatures. Its trajectory was hyperbolic. Its origin pointed toward deep interstellar space. It was not from our solar system, not from any comet family, and not from any gravitational pathway that made sense. It was an outsider, a wanderer from beyond the heliosphere. But the real shock came from its behavior. Follow-up observations revealed something impossible. As the object moved inward, expected heating never appeared. The thermal curve refused to rise. Temperature estimates hinted at a forbidden possibility. 3I Atlas might be cooling. At first, the idea was dismissed. Instrument error seemed far more likely. Teams recalibrated detectors, corrected dark frames, ran redundant scans, but the numbers did not change. Ground-based observatories joined the effort. Infrared arrays locked onto the object. Space-based instruments followed, and each dataset showed the same impossible pattern. A temperature curve dropping instead of climbing. This was not a normal interstellar visitor. It did not behave like 2I Borisov. It did not reflect sunlight like ʻOumuamua. It followed rules unfamiliar to science, perhaps rules we did not yet understand. 3I Atlas became a priority target. Observatories coordinated globally. The European Space Agency redirected assets for continuous monitoring. Thermal imagers were retuned. Spectral windows widened. Every tool pointed toward the anomaly descending toward the sun. By the time its inbound trajectory stabilized, one fact was undeniable. 3I Atlas was not simply passing through the solar system. It was rewriting expectations. And as solar radiation increased, the temperature kept falling. The paradox deepened. To understand why 3I Atlas cools as it approaches the sun, we must first understand how normal objects behave under rising solar flux. In space, heating is simple. Sunlight strikes a surface. Photons transfer energy. The surface warms. Infrared emission rises. Temperature climbs to equilibrium. Every asteroid and comet follows this rule, but 3I Atlas does not. Its measured temperature follows an inverted slope, a thermal profile collapsing downward as solar energy rises upward. It is not subtle. It is dramatic, almost engineered. Scientists modeled the object using classical radiative transfer equations. They projected the expected temperatures at every astronomical unit. 4 astronomical units should be cold but warming. 3 should be noticeably hotter. 2 should be firmly in the heating zone. At 1 astronomical unit, it should be scorching. Instead, the opposite occurred. 4 astronomical units produced a baseline. 3 revealed a cooling dip. 2 dropped further. Near 1 astronomical unit, the temperature collapsed far below prediction. This forced new categories of explanation. Extreme albedo was considered first, a surface so reflective it bounces nearly all sunlight away. But high reflectivity cannot create cooling. It only limits heating. It cannot drive temperature below its starting point. Sublimation was next. Comets sometimes cool when buried ice vaporizes, stealing heat from the nucleus. But 3I Atlas shows no coma, no jets, no outgassing of any kind. Internal conduction was tested. Heat could be driven inward rather than outward. But even perfect conduction cannot reverse heating. It can only redistribute warmth. Exotic materials were proposed. Some metamaterials expand when cooled, contract when heated, and show bizarre emissivity curves. But nothing in nature behaves at this scale. Nothing cools by absorbing more radiation. Spectral scans revealed muted infrared emissions. Thermal lines that should glow were nearly silent. The surface behaved as if swallowing heat. A multi-layered shell was hypothesized, alternating emissive and absorptive materials. A lattice designed to trap and redirect energy internally. A surface converting heat into something else. But what? Energy must go somewhere. If 3I Atlas cools, the missing heat must be hidden, stored as chemical potential, converted into mechanical tension, shifted into exotic low-frequency modes, or expelled in wavelengths we cannot detect. Another idea emerged: a thermal inversion layer, a boundary capable of flipping heat flow. Solar energy could trigger a cooling cascade, much like endothermic crystal reactions. This would not violate thermodynamics. It would simply exploit them in ways we've never seen. But the scale remains too clean, too smooth, too controlled. Thermal maps show coordinated cooling across the entire surface. Not random patches, not geological chaos, but synchronized behavior. The object behaves like something built. 3I Atlas contains contradictions stacked on contradictions. The thermal inversion is stable and consistent. Its reflectivity increases under sunlight, yet its temperature falls. It shines brighter but grows colder. Infrared suppression occurs in precise bands, not noise, not randomness, patterns, as if the object edits its own heat signature. Polarization data shows unusual rotation in reflected light, not consistent with rock or dust. More like layered conductive materials, aligned with intent. Its spin reveals uniform temperature, a sign of coordinated cooling. Radar returns show smoothness, flatness, or panel-like structure, not natural scatter. Density estimates suggest a hollow body, a shell, possibly internal framework. The missing heat remains the greatest paradox. Solar energy pours in, temperature drops, and no known emission accounts for the loss. Solar wind increases cooling instead of heating. The object carries no dust, no debris, no natural fragmentation. Minor trajectory adjustments appear near the sun, as if something inside responds subtly to radiation pressure. Light curve modulations repeat at regular intervals, not random, perhaps signaling. though no one wants to confirm it. 3I Atlas refuses all natural explanations. It cools under fire, shines without heat, behaves without randomness. If 3I Atlas is natural, then nature holds secrets far beyond current physics. Materials that cool under radiation, structures that convert heat into unseen forms. If it is artificial, the implications expand dramatically. Its cooling system could be a stabilizer, a shield, a way to operate near stars without overheating. Such technology would revolutionize spacecraft design. Cold holes under extreme radiation could open new frontiers. Its energy conversion mechanism could unlock new forms of storage, new states of matter, and entirely new engineering principles. There may be more objects like it, wandering cold through the light of other suns. As 3I Atlas falls inward, its temperature keeps dropping. The curve does not reverse. Future missions may approach, but its cooling field could distort instruments. Still, the pursuit continues. Because 3I Atlas offers a doorway to the unknown, the greatest mystery is not how it cools, but why it must. As the sun grows hotter, 3I Atlas grows colder. A contradiction in motion. A silent message written in thermal impossibility. And perhaps, when we finally understand why it freezes in the heart of fire, we will learn something profound about the universe and about ourselves. 3I Atlas continues its descent, and the mystery deepens.